Hi guys, turn to 3.1c classwork on page 21 please. You should have a nice sharp pencil and a ruler. This of course is not a nice sharp pencil, but sharp enough. Pencil is the operative word, make sure you have a pencil. Okay, so remember on Thursday or Friday we were watching Tom and Jerry, and the homework that we graded yesterday was all about where two lines meet, and that's what this section is really dealing with, is where do two lines meet. So we have two equations right here. One of them is in slope-intercept form, and let's remember what that is. Y equals mx plus b. This one looks just like that, but this one we might need to do some work to. So how would I make this equation into slope-intercept form? And we've done plenty of practice with this. We just did our retake and everything. So you subtract 2x to get y by itself, and you end up with y equals not 4 minus 2x, if we want it to look like this, but negative 2x plus 4. Now we're able to graph both these equations because we know what the slope and the y-intercept are. Remember, this is m and this is b. So let's do one at a time. Let's begin with the one I just pointed to. Where would this graph begin? Right here would be, of course, down 2. And then my slope is 4, and remember it's like a rise and a run, so you're going to rise 1, 2, 3, 4 and run 1, and repeat that until you run out of room. 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, and do it the opposite direction as well. Down 4 and left 1, down 1, 2, 3, 4, left 1. And of course, using your ruler, you're going to connect the points to make your line extend as far as you can. And put arrows at the end. Okay, so we've just graphed this line. That's done. Now let's graph this new line that we have isolated y for. So where does this graph begin? And hopefully you know that it begins at positive 4, which would be up here. And then this graph has a rise of negative 2 over 1, which means we go down 2 and right 1. And I'm going to stop there because what just happened? Hopefully you see that the two lines are about to, or have, intersected at this point. But let's continue anyway. Down 2, right 1, down 2, right 1, and so on until you run out of room, and do it in the opposite direction. Up 2, left 1, up 2, left 1, etc. Now draw your two lines, draw your second line using your ruler, put arrows at the end. And again, I circle that point because it is going to answer all these questions over here for us. So state the coordinates of the point of intersection. That is right there. Name that point. And remember, you walk to the elevator, so it's to the right 1 and up 2. So it's 1, 2. Using the original equations, verify, and remember that means to plug in. Whenever we verify, we plug in that point in the intersection to satisfy, and that just means that it's going to be a check, okay? So let's start with the one that's already done for us. So y equals 4x minus 2, and then the other one is y equals negative 2x plus 4. And we're just going to plug in this x and this y and see if it works. So we replace y with 2, we replace x with 1, and see if it works. So does 2 equal 4 minus 1 is 4 minus 2 is 2? It works. And let's do it here. Again, replace y with 2, negative 2 times what the x is, which is 1, plus 4 more. Simplify that. Does 2 equal negative 2 times 1 plus 4? Negative 2 times 1 is negative 2 plus 4, which is 2. It works. So you have just verified that that point works in both equations, and the graph shows us that they're supposed to intersect at that point. Okay, go ahead and read this paragraph to yourselves. I'm going to press pause and come back to you so the substitute teacher can press pause while you guys read this and talk about what we just did. Make sure you pay attention to every problem we're doing, because this homework that you're about to do is just like this. This time we're going backwards. They're asking us if this ordered pair of 0, negative 5 is the solution, and then we're going to explain and verify by graphing. So we're going to go backwards. Up here, we graphed first and then checked to see if it worked. Down here, we're going to go backwards. We're going to first see if this ordered pair works and then check and see if it graphs properly. So again, take your x and y and plug them in. So in the top one, you're going to replace y with negative 5 equals 2 times the x value of 0 minus 5, and see if we get a true statement. So negative 5 equals, what's 2 times 0 is nothing, so it works in the top one. Now let's do it into the bottom one. So again, you're replacing x with 0 and y with negative 5. So 4 times 0 plus 5 times negative 5 should equal 25, and let's see if that's true. This is nothing. This is negative 25, which does not equal 25. So this one's no good. Okay, so what that means is that these two equations don't intersect at that ordered pair, and now we got to prove it. So let's graph the top one. There's M, there's B. Begin at negative 5 and rise how much? 2 and run 1. Rise 2, run 1. Continue to rise 2 and run 1 until you run out of room forever. Like so. And then we're going to connect that with a ruler in just a moment. But for the bottom equation, I have to isolate y. And again, you should be pretty good at this. So if we start with the equation as written, let's subtract 4x from both sides. And everything I'm writing, you should be writing neatly and completely. Don't write 25 minus 4x. Write minus 4x plus 25 because we want to be in slope-intercept form. Divide everything by 5. And you end up with y equals, that's just a fraction, negative 4/5 x plus 5. There's your b. There's your m. Where do you begin this graph? At 5. And then you go down 4 and write 1, 2, 3, 4, 5. Down 1, 2, 3, 4, right 1, 2, 3, 4, 5. Up 4, left 1, 2, 3, 4, 5. Now I'm going to connect the two, all the points. And actually I counted wrong on that one. It should be there. And then this guy goes here. And clearly they do not intersect at 0, negative 5, which would be down here, do they? Okay, once again, I'm going to press pause, so go ahead and turn the page, and let's finish the rest of your assignment. Okay, I had to sharpen my pencil so I get good, nice, neat points on this tiny little graph. So all it's asking us to do is graph the equations and find the solution. And really, what you read in this paragraph is that the solution is the point where the two lines intersect. That is the solution. So, super fast. What's wrong with this equation and what's wrong with this equation? Why can't we graph them as they sit? Your answer should be because you need to isolate y first, get m and b. That's true for all of these. So since number 3 has some work to do, let's start with number 4, which already has y isolated. We're going to come back and do number 3, but let's begin with number 4. So for this one, clearly that's the slope, and what's the b that you don't see? 0. And there's your slope, and there's your y-intercept there. So let's graph the top equation. Begin at 0, and then go down to right 1, down to right 1. And see how a sharper pencil makes a bit of a difference in terms of finding where the points are. Up 2, left 0, up 2, left 0, up 2, left 1, up 2, left 1, and so forth. Again, I'm going to connect this in a moment, but let's graph the other line. So this one's done. Now let's graph that one, which begins at negative 1, 2, 3. And then what does it say to do? It says to go down 1 and right 2. And look what just happened. Down 1, right 2. 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 Up 1, left 2. Up 1, left 2, etc. So I think that's enough, because really what we're doing is we're looking for where these 2 points are going, or these 2 lines are going to intersect, and I think we already found it. Now, there it is. Name that point. Where is that point on the graph? Let's see, 1, 2, 1, 2, 3, 4. So the solution to this would be -2, positive 2, go to the right 2, and down 4. So the solution is +2, -4. Okay, and then we have to verify it by plugging that in and see if it works. And I'm going to have the teacher press pause again. I'm going to verify it while you guys plug this in, these two x and y's, into these equations and see if it's true. Then when the video restarts, you'll see the answers. Okay, so I plugged it into both of them, and I got a true statement. -4 equals -4, and -4 equals -4 for both. So this is the solution to this ordered pair. So now the next thing we're going to do is, again, we're going to come back and do not necessarily all of these, but we've got to try a couple of them here because we've got a lot of classwork to do, and you're going to have to watch a second video for us to get through it. So what we're going to do is let's take a look at this number 3 here that we skipped initially. So now since we have to isolate y first, clearly in this equation you've got to subtract 2x from both sides, and then just rewrite it down here. And when I subtract 2x, you get y equals -2x plus 14. And now y is by itself. And for the bottom equation, you need to subtract x from both sides. And if I rewrite that here, I get y equals -1x plus 11. Now we're going to graph these two on the same coordinate plane. So here's M, here's B, here's M, here's B. Let's begin at the top. B is 14, which is way up here. And you're going to go down 2, right 1, down 2, right 1, down 2, right 1, and so on and so forth for a little while until we can see that we're running out of light, apparently. Hang on. Okay, so now that's that line done. I'll connect it in just a moment. Now let's graph the bottom line. Again, here's M, here's B. Begin at 11, and then you're going to go down 1, right 1, down 1, right 1, down 1, right 1. Now this one's kind of tricky to see. Zoom in for you here. Started at 11, I went down 1 and right 1. Then I went down 1 and right 1. Then I went down 1 and right 1, and I just hit the other graph. Down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, etc., etc. Just like that. So now again, this is a bit of a mess if you're not careful. You've got to be very careful with your graphs. And this guy right here. Okay. Now name that point. And to me, it's 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Should be 3, 8. We're going to verify that in one minute here. So we're going to plug in 3, 8 into the original equations and see if it works. Remember, this is x, this is y. So 2 times 3, I'm plugging it in right here, plus 8 should equal 14. And 6 plus 8 does equal 14. Now plug it into the bottom. 3 and 8 for x and y. Does 3 plus 8 equal 11? And clearly it does. We have verified. Okay, you're going to need to watch the second video for us to finish the classwork for today. Can't wait to turn on that second video. Thank you. Take a break right now, because I am.